Okay, let's do question 6. A train is initially at rest, accelerates uniformly until its speed reaches 8 meters per second within 25 seconds. For the next 200 seconds, the train continues its journey with constant speed before it slows down uniformly and comes to a complete stop in 20 seconds. So now we have to sketch a labeled graph of speed versus time for this whole journey. Okay, so let's do that. Let me just draw the axis. So this is our speed in meter per second. Then we have our time in seconds. Okay, so this train is basically at rest for the first few for the first second, for the first 0 seconds, and then it goes from 0 to 8 meter per second within 25 seconds. So assuming this is 25 seconds, so it is increasing uniformly. Let me just do this. Okay, and then it for the next 200 seconds, I'm just gonna draw anywhere. Okay, it's not to scale obviously. So this is 200 after 200 for the next 200 seconds, which is 225 lah di sini. Okay, dia moves at constant speed. Okay, moves at constant speed, and then an additional 20 seconds means dia stop sudah. Dia cakap next 20 seconds dia go complete stop. 20 plus 225 is 245. So you'll get something like this. Okay, so this is something like this. So let's just do this. 8. Okay, so that is the graph of speed versus time. Okay, so make sure all are labeled along with the units, and then you're done for question A. Now question B pula, calculate the acceleration of the train for these 3 parts of the journey. Okay, so now we have to find the acceleration pula. So for a speed against time graph, what does the gradient tells you? The gradient of this graph, remember, the gradient of this graph will be telling us about the acceleration. Okay, so based on that, we can then just calculate the gradient for each part lah, first, second, third. Okay, so should I label? I think I should. So this is first, this is second, this is third part. Okay, so the first part is, we can find that the acceleration is, I put 1, it is delta v over delta t. So it is 8 minus 0 over 25 minus 0. Sorry. So you'll then get 0.32 meter per second square to be the acceleration. And then for the second part, which is a 2, it is again delta v over delta t, but we know that this is a constant velocity. So constant velocity means acceleration is 0 as well, and then you can see as well the gradient is 0 at this second part, so 0. And then final part, which is the third part, delta v over delta t, which is final minus initial, so 0 minus 8 over 245 minus 225, which is 20 yang just now. Lepas tu, you'll then get negative 8 divided by 20, which is negative 0.4 meter per second square. Okay, so that is question B. And then the final question is asking us about the total distance traveled. So we have to find the total distance traveled, and we know that if it is a speed against time graph, the total distance can be calculated by calculating the area under the graph. Okay, so area under the graph will tells us about the total distance lah. So I'm just gonna conclude that the distance is equal to 1780 meter. Okay, so apa yang kamu buat is just find the area under the graph ah. Okay, so this is just triangle. This is trapezium lah. So this is triangle. Okay, so that is question 6.